Hi everyone, in this question we have a 6-character password to be chosen from the following 9 characters. We have the letters A, B, E, F, numbers 5, 8, 9, and symbols asterisk and a $sign. Each character may be used only once in any password. Because we're dealing with passwords, the order is important. That means we're dealing with permutations. So we need to find a number of different 6-character passwords that can be chosen if, in part A, there are no restrictions. So you can see if there are no restrictions, the letters, numbers, and symbols can go wherever they like. The only restriction is that we can only use each one time. So for part A, we can put any one of the 9 letters, numbers, or symbols in the first position. So we write 9. One of them has been used, so there are only 8 options for the second position, and so on. So we have 9, 8, 7, 6, 5, 4. This will give us the number of permutations if there are no restrictions. So that's calculated as 9 times 8 times 7 times 6 times 5 times 4. That will give 60,480 permutations. The other way to look at this is to use the permutation formula. Let's write it here. So we have NPR. So this is n factorial divided by n minus r factorial. So in part A, we have 9 characters to choose from, and we have to choose 6 characters. So this is 9p6. Using our permutations formula, we'll have 9 factorial divided by 9 minus 6 factorial, which gives us 9 factorial on 3 factorial. And if you were to calculate that, you will indeed get 60,480. That's part A finished. Let's go on to part B. So in part B, the password must consist of 2 letters, 2 numbers, and 2 symbols in that order. So the first 2 positions are taken by letters, the second 2 positions are taken by numbers, and the last 2 positions are taken by symbols. So for the letters, there are 4 to choose from. That could go into the first position, and that leaves 3 options for the second position for letters. For numbers, there are 3 options for the first position, which leaves 2 options for the second position. For symbols, there are 2 options for the first position, and in the last position, there is 1 option for symbols. So we can calculate the number of permutations as 4 times 3 times 3 times 2 times 2 times 1. And that will give us 144 permutations. We can also use our permutations formula to do this. So for the letters, we have 4 letters to choose from for 2 positions, multiplied by numbers. So we have 3 numbers to choose from for 2 positions. So for symbols, we have 2 symbols to choose from for 2 positions. So writing this out using our permutations formula, we have 4 factorial on 2 factorial times 3 factorial on 1 factorial times 2 factorial on 0 factorial. So that will give us 24 on 2 times 6 on 1 times 2 on 1. Note the special case where 0 factorial equals 1. So that will give us 12 times 6 times 2, which is indeed 144. Let's move on to part C. In part C, the password must start and finish with a symbol. So for the first position, there are 2 options for a symbol. So we write 2 here, which leaves the last position having 1 option. The remaining letters and numbers can be arranged as 7 in this position. When 1 has been used, we'll have 6 in this position, and so on. 6, 5, 4. So that will give us 2 times 7 times 6 times 5 times 4, which gives us 1,680 permutations where we have a symbol in the first and last position. Thanks for watching.